Okay, so what I've done is on that two-stage attempt that failed, the second stage didn't ignite. I was using a piece of this white visco. This is fast visco. This is the 0.1 to 0.4 seconds per foot stuff, and I had rammed it up in the nozzle of the second stage, but this stuff burns so violently fast that apparently it probably propelled itself and dislodged itself from the second stage. It didn't work. Regardless, that's what matters. So anyway, what I'm trying here is I have dipped one end of this fast visco into my nitrocellulose lacquer mixed with black powder with a touch of aluminum powder mix. This is the same composition that I use on my igniters, and it's worked very well for me now. So I dipped that in that mix, and then I shoved it up in there kind of like glue to glue that into place to make sure that visco hopefully will not come out of this motor. The other end I dipped in the same composition and then rolled it in some very finely granulated, probably won't show up that well, but it's not terribly important, in some very fine black powder, granulated black powder, and that's to help it take fire. Now the motor here, because I was in a hurry, I just want to find out if the fuse will actually ignite this with this composition gluing it into place. I just want to find out if that combination will actually ignite one of these motors. So what I did to save time is, and I pressed this yesterday, still went ahead and put it through the dryer anyway, is I did not press the composition wet, I pressed it dry. This was just mill dust, black powder mill dust, right out of the ball mill. Boom, into the motor. I pressed it to double the pressure that I normally would use. Normally I'm hitting somewhere in the neighborhood of about 3,000 psi. I hit it to about 6,000 psi to hopefully get a solid single fuel grain. But I'm not sure that it's going to work. I've never done that before. I've always dampened the composition, at least 3% water by weight. So I have not done that. So what I'm going to do on this, that visco, remember, is 0.1 to 0.4 seconds per foot. And you may notice that there's a little bit less than a foot there. That's going to burn in hundredths of a second. So I don't want to be anywhere near this thing when it goes off, just in case the motor catastrophically fails. If it blows up like some of the other ones that I've taken videos of, I don't want to be standing right next to this thing, and there's no way I can light it and run. So what I'm going to do, because by the time I'm running, it's already going to have done what it's going to do. So what I've done is I've cut a piece of slower visco here, and I'm going to tape that to the side of the fast visco, and I've got about 6 inches of this stuff here. That's going to give me plenty of time to get to a safe distance. Anyway, I'm going to tape that on, take this outside, set it up in the rocket flying stick test motor launchy thingy that doubles as a T-post driver, and we'll see what this does. Alright, here it is, and I've taped that slow visco to the side of it, and I'm going to light that, and then I'm going to run back here. I don't have any weights on it to act as shrapnel this time. That didn't cause me a problem before, but it sure was dangerous. I shouldn't have done that. Anyway, live and learn. So I'm going to light this thing. Oh, there we go. That worked. Wow, that went awesome. Okay, that worked.